Hi and welcome back. In this exercise, we need to write a function which count all the prime numbers in the given list. So this is our objective. Let's start from the main program. We are given a list of some numbers, some integers are there, and few of them are prime numbers. And what we are doing is we are simply calling a function count primes and passing this list to it. Then we have this function count primes. What it does is it basically iterates over this particular list, and every time it checks whether the particular index number in this particular list is a prime number or not. If it sees that this is a prime number, and it simply increments the counter which is for the prime numbers. So this prime counter is initialized to 0 here, and every time in each iteration of this loop, it checks whether the indexed element of this list is a prime number using this further function is prime. And if it is true, if this function returns true, that means if this particular number is a prime number, then it increments this counter, prime counter. And this index variable is just to go to the next iteration of the loop. And finally, once it has iterated over all the elements of the list, then it returns the calculated prime counter. This is what our objective is, to count the prime numbers in the given list. Now let's see the definition of this function is prime, which checks whether a given number is a prime number or not. So it simply accepts a number, and as we discussed before also in our past chapters, a number is a prime number if it is divisible by any other number, basically if it has any other factor, and a factor can only be less than the given number. So this program, what it is doing is, it is iterating from 2 to n, factor is less than num, basically 2 to n minus 1, and it checks whether the number is divisible by this particular factor, let's say 2, 3, 4 and so on. At any point in time, if this number gets divisible, then immediately this function returns false. No need to check further. In that case, number is not a prime number, so it can return false. And finally, this function can return true. If this number does not get divisible by any other number from 2 to n minus 1, then we can say that this particular number is a prime number. So this function returns true. So that is how this function is prime is working. Now we have seen this functionality of is prime and count primes. So we are able to use these functions in our main program. So that is why we are calling here simply count primes and passing the complete list to it. Let's try to run this. It is saying count of prime numbers in the list is 4. So as we see our list here, 3 is a prime number, 2 is a prime number, 5 is a prime number, and after that 13 is a prime number. So indeed there are 4 prime numbers in this list. Now let's say we add one more prime number to it, let's say 17, and try to run this again. Now we can see that the prime numbers have changed from 4 to 5. So indeed this program is working fine. It is able to calculate correctly the total number of prime numbers in the given list. So this is one of the solution of the given problem. There can be other solutions as well. So thank you for your time in this particular chapter. See you in the next one. Thank you.